There is a story that gets told so often, in so many variations, across so many different families, that at some point you have to stop calling it anecdotal and start asking what it's actually evidence of. The version goes something like this. Someone in the house is sick, or grieving, or in the specific kind of quiet pain that doesn't announce itself loudly, that just settles into a person and makes them still and heavy and slightly absent. And the dog, or the cat, or sometimes an animal they didn't even know particularly well, finds them, comes to them specifically, sits with them or presses against them, or simply positions itself nearby and stays there, in a way that it doesn't do on ordinary days when everything is fine. Most people who have experienced this explain it away. They tell themselves the animal is just seeking warmth, or following routine, or responding to the reduced activity level of a sick person who is lying still and therefore less disruptive. They reach for explanations that preserve the comfortable idea that what happened was coincidence and mechanism, rather than something that would require them to take more seriously what is happening on the other side of the species barrier. But here is what those explanations consistently fail to account for. The specificity, not just that an animal sought out a human when the human was unwell, but that in household after documented household across species after species, the animal sought out the specific human who was unwell, in preference to other humans in the same space who were not. That is not behavior consistent with seeking warmth or responding to reduced activity. That is behavior consistent with detecting something specific about a specific individual and responding to that specific detection. So the question is real. Do animals actually know when a human is sick or sad? And the scientific answer, assembled from converging evidence across biochemistry, ethology, neuroscience, and clinical research, is yes, in ways that are more precise, more physiologically grounded, and more practically significant than most people have ever been told. And the final piece of evidence in this video, a clinical trial published in a peer-reviewed medical journal, documents a capability so specific that it should fundamentally change how you think about what animals are doing when they sit with you on your worst days. Stay with me. This is the story of what animals are actually sensing when they seem to know something is wrong, and it is more extraordinary than the story most people tell themselves about it. Let's begin with the most underappreciated sensory system in this entire topic, because understanding it is the foundation of everything that follows. The human sense of smell is genuinely poor by mammalian standards, not the worst in the animal kingdom, but dramatically less sensitive than the olfactory systems of the animals most commonly involved in human-animal illness detection. A dog's nose contains approximately 300 million olfactory receptors. The human nose contains roughly 6 million. The olfactory cortex, the brain region devoted to processing smell information, makes up approximately 12% of a dog's brain and a much smaller fraction of the human brain. A dog does not just smell more things than a human does. It smells the world in a different dimension of experience entirely, processing olfactory information with a richness and a resolution that has no real human equivalent. What this means in practical terms is that a dog in the same room as a human is receiving continuous, detailed, constantly updating chemical information about that human's physiological state. Not in the vague, impressionistic way that humans experience smell, but in a precise, high-resolution chemical read of what is happening inside that person's body, communicated through the volatile organic compounds they are continuously exhaling and emitting through their skin. Every change in a person's physiology, every shift in hormonal levels, every alteration in metabolic processes, every change in immune system activity is reflected in changes in the specific mix of volatile organic compounds the person produces. And the dog's olfactory system is sensitive enough and discriminating enough to detect and process those changes at concentrations that are entirely invisible to human perception. This is not a theoretical possibility. It is a documented, measurable, experimentally confirmed reality. And it completely reframes the question of whether animals know when a human is sick, from a question about animal intuition or emotional connection into a question about an information channel that exists, that carries real data, and that certain animals are equipped to receive with a sensitivity that we are only beginning to systematically study. The most extensively researched specific capability in this area is cancer detection by dogs, and the research results are striking enough that they have moved from curiosity to active clinical investigation to pilot programs in actual medical settings. The story begins with a case report published in The Lancet in 1989, documenting a dog that repeatedly sniffed and attempted to bite a specific lesion on its owner's leg, a lesion that a dermatologist subsequently identified as a malignant melanoma. The dog's persistent attention to that specific location was what prompted the owner to seek medical evaluation. What followed over the subsequent 3 decades was a progressively more rigorous body of research investigating whether dogs could reliably detect cancer through scent, and the results have consistently been positive enough to sustain serious clinical interest. A study published in the British Medical Journal in 2004 trained dogs to detect bladder cancer from urine samples by presenting them with samples from confirmed cancer patients mixed with samples from healthy controls. The dogs identified the cancer samples correctly at rates significantly above chance. A 2011 study in the journal Gut trained dogs to detect colorectal cancer from breath and stool samples, achieving sensitivity of approximately 91% and specificity of approximately 99%. An Italian study published in 2015 reported dogs detecting prostate cancer from urine samples with greater than 98% accuracy. These numbers are remarkable in context. Prostate-specific antigen testing, one of the standard clinical tools for prostate cancer screening, has a specificity of approximately 91%. The dogs in the Italian study were outperforming a standard clinical test. They were detecting a malignancy through a mechanism that researchers are still working to fully characterize, identifying specific volatile organic compounds in the urine of cancer patients that differ from the compounds produced by healthy individuals. Compounds that the dogs were clearly sensitive to at concentrations far below any current laboratory instrument's detection threshold. The dog sitting near a sick person is not doing something mysterious or unexplained. It is responding to real chemical information that the person's changed physiology is broadcasting continuously through the air. The dog cannot tell you what the information means in conceptual terms. It cannot diagnose. It cannot articulate. But it is receiving data about the person's physiological state with a sensitivity that exceeds any instrument currently used in clinical medicine. And its behavior reflects that reception in ways that have been consistent enough, and specific enough, and directional enough that the clinical research community has taken it seriously enough to fund, conduct, and publish multiple controlled trials. Now here is where the story expands beyond cancer, and into the territory of the question most people are actually asking when they ask whether animals know when we are sick or sad. Stay with this, because the next section of the research covers the detection of emotional and psychological states, and it is where the evidence gets most directly relevant to the experience most people have actually had with animals. Fear, stress, anxiety, grief, and clinical depression are not purely psychological states. They are physiological states. They alter hormone levels, change metabolic rates, modify the activity of the immune system, alter heart rate and blood pressure, and produce characteristic changes in the mix of volatile organic compounds that a person exhales and emits through their skin. Every emotional state has a biochemical signature, and animals with sensitive olfactory systems are reading those biochemical signatures continuously. The research on dog detection of human fear is among the clearest demonstrations of this. A study published in the journal Chemical Senses in 2018 collected sweat samples from human subjects during a skydiving experience, a context designed to produce genuine fear, and from the same subjects in a resting state. Dogs that had no training in fear detection, pets with no specific conditioning for this task, were exposed to both sample types. The dogs showed significantly different behavioral responses to the fear samples versus the neutral samples, with increased alertness and stress indicating behaviors in response to the fear samples. They were detecting a real chemical difference between a person in a fear state and a person in a relaxed state, and that detection was producing observable behavioral changes. This is why the dog that becomes anxious when its owner is frightened, the dog that reacts to tension in the household before any human behavior has made the tension obvious, is not reading minds or responding to subtle body language alone. It is responding to a chemical broadcast that is as real and as information-rich as anything in the visual or auditory domain, just operating in a sensory channel that humans cannot access, and therefore tend to systematically underestimate. Grief presents a particularly interesting case because the physiological signature of grief is distinct from fear or general stress, and has been studied in several animal-human interaction contexts. The cortisol elevation, the changes in serotonin and dopamine signaling, the altered immune function, the specific mix of stress hormones that accompanies sustained grief in humans, are all biochemically detectable in principle through olfaction. Research on dogs living with bereaved owners has documented behavioral changes in the dogs that correlate with the human's grief state. Changes including reduced playfulness, increased proximity seeking toward the grieving owner, and what researchers have described as behavioral dampening consistent with social referencing of the owner's emotional state. The social referencing component is important because it introduces a second mechanism beyond pure olfaction. Animals, particularly those with extended histories of coevolution with humans like dogs, have developed sensitivity to human emotional cues across multiple channels simultaneously. Facial expression, body posture, vocal tone, movement patterns, and scent signals are all being processed concurrently, and the animal's behavioral response is the integrated output of all of those information streams together. The dog that comes to sit with someone who is sad is not responding only to the biochemical signature of sadness. It is also responding to the reduced movement, the different vocal patterns, the facial expression changes, and the postural changes that accompany human sadness, all of which are genuinely informative signals about the human state. Now here is the moment in this story that should genuinely stop you. The piece of evidence that goes beyond everything covered so far and documents an animal detection capability that most people would not believe was possible until they encountered the research directly. Dogs have been trained to detect the onset of hypoglycemic episodes in diabetic patients, low blood sugar events that can be medically dangerous and that occur with insufficient warning through purely internal perception to allow reliable self-management in many patients. The dogs are detecting the beginning of a hypoglycemic episode before the patient experiences any subjective symptoms, before the patient knows their blood sugar is dropping, before any external behavioral change has occurred that would provide a behavioral cue. The dog is responding to a physiological change that is invisible by any external measure and that the patient themselves cannot yet perceive, and it is responding in time to allow the patient to take preventive action that avoids the emergency. Research on diabetic alert dogs published in journals including PLOS1 and Diabetes Care has confirmed this capability across multiple studies. The mechanism appears to involve the detection of isoprene, a volatile organic compound produced by the body during the metabolic changes associated with hypoglycemia, which the dogs detect through olfaction at concentrations that precede the physiological changes that would produce symptoms. The dog knows the patient is becoming ill before the patient does, before any symptom exists, through a chemical signal that no human can perceive and no clinical instrument has reliably matched for early detection of the event. Seizure alert dogs present a similar case, and one that is even more mechanistically mysterious because the biological basis of pre-seizure scent changes is less well characterized than in the hypoglycemia case. Nevertheless, the behavioral evidence that some dogs reliably alert to impending seizures in epileptic patients is strong enough that seizure alert dogs are recognized as legitimate service animals in multiple countries and have been the subject of peer-reviewed clinical research. A study published in Scientific Reports in 2019 found that dogs could distinguish seizure-associated human scent samples from non-seizure samples with accuracy rates of approximately 67 to 100% depending on the individual dog, suggesting genuine olfactory detection of a specific physiological signature associated with seizure events. The implication is that the dog is detecting something in the seizure patient's scent that changes before the seizure itself occurs, providing a warning that the patient's own neurology cannot generate. What that compound is has not been definitively identified, but the behavioral evidence that the dogs are detecting it is strong enough to have changed how some epileptic patients manage their daily lives, and the research supporting it has been published in peer-reviewed journals rather than existing only in anecdote. Here is where I want to take a step back from the specific research findings and say something about the larger picture this evidence is building, because there is a pattern running through all of it that is worth naming explicitly. In case after case, across different species, different conditions, different physiological states, and different research methodologies, the evidence points toward the same conclusion. Animals that live in close proximity to humans are continuously receiving real information about the human's physiological and emotional states through sensory channels, primarily, but not exclusively, olfactory, that humans do not have meaningful access to. They are not imagining something is wrong. They are not responding to unconscious behavioral cues that clever researchers might explain away. In the best documented cases, they are detecting real biochemical signals of real physiological changes, in some cases before those changes are detectable by any other means. The behavior that follows from that detection, the coming close, the staying nearby, the gentle, persistent presence that so many people have described from their animals during illness or grief, is the behavioral expression of information that is genuinely there. The animal is not performing. It is responding to something it actually perceives, with a social behavior that in many cases, based on what we know about the neurochemistry of human-animal contact, actually helps. The research on the physiological effects of human-animal contact during illness and distress is a separate literature from the detection literature, but it converges on the same place. Contact with an animal, particularly contact with a familiar companion animal, produces measurable reductions in cortisol levels in distressed humans, measurable increases in oxytocin, and measurable reductions in blood pressure and heart rate. These are not small effects that require careful statistics to find. They are robust effects, replicated across multiple studies, large enough to be clinically significant in some contexts. The animal sitting with someone who is sick or sad is not just providing psychological comfort in some vague, unquantifiable sense. It is producing real, measurable physiological changes in the person it is sitting with through the mechanism of contact and social presence. Which means the interaction is genuinely bilateral. The animal detects the human's changed state. The animal responds by providing close presence. The human's physiology is measurably improved by that presence. In some cases, the animal's own oxytocin levels also rise during the contact, suggesting that the interaction is producing a physiological response in the animal as well, that something real is passing between them in both directions during those quiet moments when an animal settles next to someone who is suffering. What animals are doing when they come to sit with a sick or grieving person is not a mystery to be explained away or a coincidence to be rationalized. It is a biological interaction of genuine sophistication, built on real sensory detection of real physiological information, expressed through behavioral responses that have real physiological effects on both participants. The fact that we cannot fully see the mechanism from the human side does not make it less real. It makes it a reminder of how much of the world around us is operating in sensory channels we cannot access and barely understand. There is one more thing I want to tell you. And it is the thing that I think matters most when all of this evidence is assembled into a single picture. The history of human relationships with domestic animals spans tens of thousands of years. The dog has been co-evolving with humans since at least 15,000 years ago, and possibly significantly longer, through a process of mutual selection in which human behavior shaped dog evolution and dog behavior shaped human social evolution simultaneously. In that context, the specific sensitivity to human physiological and emotional states that dogs have developed is not an accident. It is an evolved capability that was selected for because it was useful, in the specific context of the human-dog relationship, for it to exist. Dogs that could detect human illness or distress and respond in ways that humans found valuable were more likely to be kept, fed, and bred. Humans that found comfort and practical benefit in animals that responded to their states were more likely to maintain those relationships and support the animals within them. The specific sensitivity we are documenting in modern research, the cancer detection, the hypoglycemia alerts, the response to grief, is the product of tens of thousands of years of mutual coevolution, of a relationship so deep and so long that it has shaped the biology of both species. You are not just witnessing an animal that happens to have a good nose. You are witnessing the outcome of one of the longest coevolutionary relationships in human history, refined across thousands of generations into a sensitivity so precise that it can detect a tumor you don't know you have, a blood sugar drop you can't yet feel, a grief you haven't told anyone about. An animal shaped, in part, by the accumulated human selection pressure of thousands of years of keeping close, the ones that seemed to understand when something was wrong. So the next time an animal comes to you on a bad day and simply stays, without being invited, without being asked, without any explanation you can account for, remember what it is actually doing. It is reading you. Not with eyes or ears primarily, but with a sensory system of extraordinary precision, receiving real information about your physiological state that you yourself may not have conscious access to. It is responding to that information with the behavior that tens of thousands of years of coevolution with your species has shaped it to produce in exactly this context. It knows something is wrong. Not in the way you know things, not with words or concepts or narrative, but in the way that matters most in that moment. It is there. It detected something real. And it came. That is not coincidence. That is not projection. That is biology, ancient and precise, doing exactly what it was shaped to do. And the only thing left to decide is whether you are going to let yourself be comforted by it, or whether you are going to spend the moment explaining it away.